Looking at the last section is dealing with points of concurrency. And points of concurrency are basically identifying common intersections. Of elements. And we're going to be looking at the points of concurrency in triangles. And so there's 4 different points of concurrency that you need to be aware of. The first one is called an incenter. And incenter is the point where all 3 angle bisectors of a triangle intersect. And so if I just sketch here a triangle, and then I'm also just going to sketch the angle bisectors. We'll go through in more detail with actual constructions next class. But if you were to draw in all of your angle bisectors, okay, so that means that these 2 angles are equal, these 2 are equal, and these 2 are equal. And the point where they all intersect is called the incenter. The incenter provides a little additional information beside this. This also happens to be the center of an inscribed circle. Okay, so what that means is if you take this center point and you draw in a perpendicular to one of the sides, it doesn't matter which one, that perpendicular is going to be a radius of a circle that will be contained completely within this triangle. Right, so you can create an inscribed circle, you can find the incenter, or you can find the point where angle bisectors intersect, and all of those would be involving this point of concurrency. The second point that you need to be aware of is called a circumcenter. This is the point where all 3 perpendicular bisectors of a triangle intersect. Okay, so once again, if we take a look at a triangle and we draw in the perpendicular bisectors. And so again, what you would be doing here is you would be finding the midpoint, bless you, and the perpendicular for each of these sides. And those are all going to intersect at one common point, and that common point is called the circumcenter. And just like the incenter, it provides a little bit more information. It's the center of a circle that is what's called circumscribed about a triangle. Okay. And so with respect to that, what this means is if you connect that point of concurrency to any of the vertices, that will give you the radius of a circle that will pass through all 3 vertices of this triangle. Okay. So you can either think of this as a triangle inscribed in a circle or a circle circumscribed about a triangle. Okay, but that's finding the perpendicular bisectors of all the sides of a triangle. All right, the next one is an orthocenter. The orthocenter is the point where all 3 altitudes of a triangle intersect. Okay, so if you were to draw in each individual altitude, remember an altitude is the perpendicular segment from the vertex to the opposite base. And each of those will intersect at one common point, and that common point will be the orthocenter. It doesn't provide you any additional information. It's just the point where those altitudes will intersect. So again, altitudes mean these are all right angles or perpendiculars from the vertex to the opposite side. Okay, the final one is probably the point of concurrency that we will, or that you'll see the most as far as problems are concerned, and that's called a centroid. And that's a point where all three medians of a triangle will intersect. Okay, and so if we took a triangle, okay, the medians are the point, medians are segments that are formed when you connect the midpoint of a side to the opposite vertex. Of a triangle. And so if you were to find all three midpoints, okay, so these two sides being equal, these two sides equal, and these two segments equal. Okay, first of all, if I were just to connect these two midpoints, what would I be forming? You guys remember what that's called? Segment connecting midpoints is a midsegment. Okay, but if you take this midpoint and you connect it using a straight line to the opposite vertex, so these are examples of a centroid or a median, and where the medians all intersect is called a centroid. Okay, and the centroid does have special properties. It is the center of gravity, or the center of mass, meaning it's a balance point. If you had an object, like a firm object, that was triangular in shape, you could find where that would balance on a nail or finger or whatever by finding the centroid. It also happens to have a specific relationship. The centroid is going to divide the median into a ratio of 2 to 1. Okay, so what that means is if we looked at this upper portion versus this lower portion, the ratio would be 2 to 1. Oops. So x to 2x. Okay, and it works in reverse as well. So if I were to tell you that this length, this upper portion, the longer portion here was, let's say, 20, what does that mean this shorter portion is going to be? Half of it, or 10. And then it also, again, this is a part-to-part ratio, and I've mentioned the difference between part-to-part and part-to-whole. If we were to convert this into a part-to-whole ratio, we'd have a 2 over and a 1 over. How many total parts are there in the whole thing, if it's a ratio of parts 2 to 1? 3 total parts, right? 2 here and then 1 here. So that means 2/3 of the whole is the longer portion, 1/3 of the whole is the shorter portion. So in addition to giving it in these forms, I may also tell you that this whole length, let's say, is 21. If that's the case, then what is this shorter portion of the median? It's 1/3 of it, the whole, so 7. And then the longer portion is double 7, or 14. So you can think of it in either the 2 to 1 part-to-part ratio, or 14 is also 2/3 of the whole 21.